What's up, you friggin' geniuses? So in this video, I'm going to teach you how to simplify expressions by combining like terms. And if you need kind of an introduction into what like terms are, I'll link that video in the card above. But if you're good, we're just going to move on to the examples. And I think the best way to illustrate this is with some food analogies. So if you're hungry, hope this doesn't make you more hungry. Okay, so if I have 2 ice cream cones, this is my ice cream cone, and then I add 4 ice cream cones. How many ice cream cones do I have? Well, I have 6 ice cream cones, right? Now, what if I had 2 onions? We'll call that an onion. And then I added 4 more onions. How many onions do I have? I would have 6 onions. Okay, follow me so far? Yes? Good. I'm going to pretend you said yes. Now, what if I had 2 ice cream cones and I added 4 onions? What would that give me? Well, if I combined 2 ice cream cones with 4 onions, that would actually just give me something disgusting, and I would never do that. Okay, you can't, or well, I hope you wouldn't, want to combine ice cream with onions. I would hope that you just leave these separate. Okay, so similarly, we can apply this same theory to variables. Okay, so if I have 2 x's and I add 4 x's, then I would have 6 x's. Okay, if I had 2 y's and I added 4 y's, then I would have 6 y's. Okay, but if I had 2 x's and I added 4 y's, that would give me nothing. This is mathematically disgusting. Okay, so I would just leave the x's by themselves and the y's by themselves. Okay, so we can only add and subtract variables if they are the exact same, right? So just like I had 2 ice cream cones here and I added 4 ice cream cones, well, logically that means I'm going to have 6 ice cream cones in total. And just like we wouldn't mix ice cream with onions, we would not mix different variables. I would not mix x's and y's. I would keep those separate. And one last very important thing to understand about combining like terms is that their variables have to be the same variable and we have to have the same amount of that variable. So for example, if I had something like 2x plus 4x squared, what would this give me? Can I combine these? Well, the answer is no. Why can we not combine them? Well, as we can see, 2x, that's the same thing as 2 times x, and then 4x squared, that's the same thing as 4 times x, right? So we have this exponent 2 right here, which only gets applied to this x, okay? So that's why we have 2 x's right here. But that's the problem, right? We have 2 x's here and we only have 1 x here. So we have the same variable, right? We have an x here and we have x's here, but we only have 1 x here and we have 2 x's here. That's like saying I have chocolate here and butterscotch here. Yeah, they're both ice cream flavors, but I'm not going to mix them. So this problem up here, I would not be able to combine these. This would be as simplified as I could keep it. Okay, and one last important concept to cover is if I had something like 2xy plus 3yx. Can I combine these? Well, the answer would be yes, I could. Why can I combine them? Well, let's write it out. So 2xy, that's the same thing as 2 times x times y. All right, let's write this one out. 3yx is the same thing as 3 times y times x. Okay, as you can see, we have 1x and we have 1y. Here we have 1x and we have 1y. So since the variables match up exactly and we have the same amount on each side, these are like terms and we can add them. Okay, because again, my food analogy, right? So xy, that's the same thing as saying I have chicken and rice. And then yx, that's like saying I have rice and chicken. Is there really a difference? No, right? It's the exact same thing. I'm just saying it differently. Or I could say ham and cheese sandwich or a cheese and ham sandwich. Is there a difference? No. Okay, so the only thing I'd have to do in this problem is make the x, y, and the yx match each other. And what do I mean by that? Well, I'm gonna have to write them both as either x, y, or change them both to yx. So for example, we have 2xy, and then I'd have to change this, the 3yx, to 3xy. Okay, so now these both match, right? I have an xy here and an xy here, right? So I'm saying chicken and rice, chicken and rice. Or I could change it to yx. So I could have 2yx plus 3yx. So now I have rice and chicken, right? Now the reason we can do that is because when we multiply things together, the order in which we multiply things doesn't matter, right? We get the same answer either way. Because 2 times 4, that's equal to 8, right? What's 4 times 2? That's still equal to 8. So since we're just multiplying a bunch of things together here, we can move stuff around and it's not going to change our answer. But again, what's important is that we have the same variables and the same amount of each variable. So it doesn't matter which one we change it to, we just have to make sure that it's the same. So for example, here, 2xy plus 3xy, that would just be 5xy. Or 2yx plus 3yx, that'd be 5yx. So this was the original problem right here, right? So both of these would be acceptable answers. All right, guys, so there's your introduction on how to combine like terms. I hope the video was helpful. If you found it helpful, definitely leave a thumbs up down below. In the next video, I'm going to do a bunch of examples on how to combine like terms. I just don't want to make this video super long. So if you need to check that out, it'll be attached at the end of the video. So definitely check it out, and I'll see you there.